Okay, lesson 21 in the big green book is talking about functions. And so we are going to dive into this topic here. A lot of this is something you already know, you just probably haven't heard it discussed in this manner. So one of the most important things to understand, not that it's difficult, but it's important to understand, is the notation. The idea of how you write things. Now, you are used to seeing equations in terms of x and y. So you're used to seeing something like y equals, and then everything else. For example, x squared minus 4x plus 7. Sometimes will be a number here. By the way, if you're wondering why I drew things right here, is because here is where the reflection from the light is, and it's very difficult for you to see what I write right here, so I'm going to try to avoid that. So function notation, the idea is that we're going to put the fun back in function. Just kidding, I couldn't resist throwing that out there. Is instead of saying y equals something with x in it, we're going to write it like this. We're going to say the function f of x. And the idea here is to point out that the idea of a function is that we're going to have inputs and we have outputs. Let's say we have a box here. Let's call this our function, or say that this is a function, and the name of this function is function f. F standing for function. See if you can track that one. So in this notation, f is the name of the function. The name of the function. So it's called, this one is called function f. So I will write that in red here. And so the next thing to know is that this x right here is, this is a placeholder. It's a container or a bucket. And these parentheses here do not mean f times x. We are not multiplying here. This is something that I realize gets drilled into students in earlier years, that parentheses always mean multiplication. That's true until you talk about function notation. In this case, parentheses do not mean multiplication. What this means is that what this is it's a bucket, a container. So I'm going to try to draw a bucket, see how good I am at drawing a bucket. Pretend that's a bucket. And so the idea is this is going to be it's a placeholder. I'll write the word placeholder. Placeholder. There we go. For what it is that we're plugging into the function. And we typically use x for that. So I'll write this down here also, placeholder. And so the idea is the function here, let me write f of x again, f of x equals, this is what we call the definition of the function. This tells us what the function does. This is the magic that happens inside this function box. So what it looks like is this. If I plug, the question is, what happens when I plug something in? And what gets plugged in is what goes inside this bucket here. And so I'm going to take that bucket and square it, or whatever's in the bucket, and square it. And then I'm going to subtract 4 times that same bucket. And then I'm going to add 7. And whatever comes out after I do all that, that's the output. So let's set up a little chart here. If I set up input and output, the question is, what does this function f do? And so the definition of the function, orange, purple, how about orange? We're just going to call it an x for now. If I plug in an x into this function, x gets squared, then we subtract 4 times the x that I plugged in, and then we add 7, and what comes out is, I can't simplify that anymore, so I'm just going to say it's x squared minus 4x plus 7. Okay, what if, instead of plugging in an x, what if I plug in a number? Let's say I plugged in the number 2, keeping it easy here. I'm going to plug in a 2 as input into this function called f. So I plug in a 2 into the bucket. So I'm going to take 2 and then square it. That's 4. Let me write this off to the side. So I have 2 squared is going to give me 4, minus 4 times 2. 4 times 2 is going to be 8, and then I have a plus 7, and so this comes out to -4, plus this comes out to 3. So what happens if I plug in a 2, I get out a 3. Pretty exciting. But that's the idea. So when we say function f of x equals blah 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 x with x, this x, that x, x squared times 4x, etc. All we're doing is we're telling you what to do to the thing that you input into the function, and then whatever comes out is the output of the function. So let's do a couple examples here real quick. I did that mostly in blue. Let's go for red this time, since you can't choose because you're not watching this live. Okay, that means you can't ask questions, but you can pause, rewind, and watch it again. So, example 21.1. 21.1, we've got if f of x equals x squared plus x minus 10. Going back to our bucket analogy, we'll do that in green here. Remember, x is just our bucket. I hope you can still see this in the video. I don't want to have to re-record this. So I'm going to take whatever I put in the bucket, I'm going to square it, and then I'm going to add that same thing again, and then subtract 10. This example says that find f of 5. What that means is take 5 and plug in a 5 into that bucket. So I'm going to put a 5 in that bucket. So that means I'm going to take a 5 and square it, plus a 5 minus 10, and all that comes out to see 25, plus 5 minus 10 is minus 5, and we get it, in the end we get out 20. So our answer then would be 20. It'd be kind of like saying if I plug in a 5, I will get out a 20. Another one. 21.2. f of x equals x squared plus 1. F of x equals x squared plus 1. And it says find the f of x plus 2. Oh dear, what are we going to do here? Okay, well, remember that the x here is nothing but a bucket to hold things in. So let me draw my little bucket again. Horrible bucket. Oh well. My apologies to buckets everywhere. And so x plus 2, let's say x plus 2 is what I'm going to plug into this bucket. So whatever I plug into the bucket, I have to square. So if x plus 2 is what I'm plugging in, that means I have to square that and then add 1. So x plus 2 squared, I can do this in my head. Some of you can't, most of you can't, but I'm going to do that right now, just in the interest of time. So this x plus 2 squared is x squared plus 4x plus 4, and that's what this all comes out to. And then we have plus 1. And might have to jump down here. So we've got x squared plus 4x plus 4 plus 1 is plus 5. And they didn't tell us that x was going to stand for something. They just wanted to know what happens if I plug in an x plus 2 into this function. And so my answer would be, this is what happens to it. All right, it's 21.3. Let's see. H of theta, don't let the letters throw you. In math, we've got 26 English letters, but apparently that's not enough, and we have to go to Greek. So every now and then you run across theta or psi or phi or whatever, but it's just a letter. Let's say that h of theta is sine of theta. What this is saying is that whatever this bucket here is, or whatever we make this bucket, we're going to, whatever we plug into that bucket, we're going to take the sine of that. So then it says find for, we'll get a different blue. I will say this, I missed my markers. Oh yeah, and my students too. Let's say we have 4 radical 3 times the function h of 30 degrees. Okay? The function part here, h of whatever we plug into it, is the sine of whatever we plugged in. And so h of 30 degrees means that we are plugging in 30 degrees into the bucket. So what we're doing to that bucket is we're taking the sine of it. So the h of 30 in this problem means the sine of 30 degrees, and we are multiplying that by 4 radical 3. The sine of 30 degrees, either you know it off the top of your head, or you can look it up on your formula sheet using the reference triangles, the 30, 60, 90 reference triangle, and you should know or figure out very quickly that the sine of 30 degrees is 1/2. So you probably can't read that. So I'll put an equal sign and move to the right. So we have the 4 and the radical 3, and the sine of 30 equals 1/2. This here equals 1/2. So now if that keep going on that, 4 rad 3 times 1/2, the 2 is going to cancel this 4 to make it 2, and we're going to end up with 2 radical 3, which is as simplified as we can get that. And so that's the idea of plugging things in to a function.